Hey everyone, welcome to the Naughty Samurai channel. Today we are going to explore feature selection, a crucial step in machine learning. We will see how to pick the most important features for predicting house prices using a real housing dataset. So what is feature selection? Feature selection is the process of picking the most important features from your dataset that actually helps your model make good predictions. Not all features are equally useful. Some may be irrelevant or noisy. Feature selection helps you focus only on the features that matter. Think of this dataset that we are using here. This is a dataset designed for predicting the price of a house. There are 10 features here in total. To determine the price of the house, you actually do not need all these features. You have to select only a handful of them which actually matters. Features like hot water heating or air conditioning are irrelevant because not all houses have this installed regardless of the price. They can also be installed individually, so they are not an important factor affecting the house prices. So these features can be dropped without worrying about the vacuum created in the dataset, as they are not as important as the rest of the features. For instance, you should not drop a feature like whether the house is connected to the main road or not, because the price of an apartment can of course vary on this basis. If an apartment is in Manhattan and is connected to the main road, its price will obviously be higher than a similar apartment that is not connected to the main road and is based in a remote area. Because being on a main road usually means better accessibility, closer to shops and transport, and also higher demand. Secondly, even if two apartments have the same area and number of bedrooms, the one on the main road will generally sell for more. Now let's explore the three significant ways feature selection helps in model training. It deals with three main problems. Problem 1 is irrelevant features. Not all features may impact price equally. For example, hot water heating might only exist in 5% of houses, so it's not very useful. The second problem is overfitting. Including each and every feature may make the model memorize the data patterns instead of actually learning and analyzing the general trends. And the third problem is the computational power. If there are more features, then the training speed will be slower, which means it will be harder to interpret the data for the model. There are mainly two feature selection techniques. First is the forward elimination technique, where you start with no features and add them one by one based on which improves the model accuracy the most. And second comes the backward elimination technique, where you start with all the features and remove them one by one based on which has the least impact on the model accuracy. Let's say we have 5 features x1, x2, x3, x4 and x5. In step 1, first we have to test each feature individually and find out its accuracy score. So suppose after finding out the accuracy score, we get 40% for x1, 50 for x2, 25 for x3, 35 for x4 and 20% for x5. As x2 has the highest accuracy score, we carry on with it to the second step. Now in step 2, we add all the features with x2 and calculate their accuracy score. After adding them up, the sum of x2 and x4 yields the highest accuracy, so we will go forward with it to the next step. But we need to make sure that the accuracy we get in the step 2 is greater than the one we got in the first step. If not, then we will go on with the individual feature x2 only. Now this will go on and on until we get the highest accuracy. Now on the contrary, instead of starting with individual features, we start with all of them together and drop them one by one. Let's say in step 1, x1, x2, x3, x4 and x5 combined has an accuracy score of 78%. Now in step 2, we drop each feature individually and calculate each of their accuracy score. We go forward with the one which has more accuracy than the one in step 1. If we don't get it, we continue with all 5 features. And if we do get a better accuracy after dropping one, we go to the third step where we drop one more feature. We go on until we get the highest accuracy score. The very first and foremost thing we need to do, as always, is importing the libraries after installing them. There is another library that we will need to install in order to move forward with our task, which is this. Now we will download the dataset directly from KaggleHub. I would be attaching the link to this in the description box below, so do check that out. This is the file that we are dealing with. The name is housing.csv. And now finally, I will print the first 10 rows of the dataset, and this is our dataset that we are going to work with. So before moving forward and applying the forward elimination and backward elimination techniques, we first have to deal with what our inputs and outputs are. So what is our output here? Like, what do we want to derive? So as you can see here, all these features are used for deriving this main thing, which is the price column. So this column needs to be the output value and the rest of the features need to be input values. So we will divide or distribute this dataset accordingly. So as I said, the price column will be the output column and the rest of the columns will be considered as input column. So we will code it out accordingly. We will write y is equals to the output column. So the name of the column will be price, and for dealing with the rest of the columns, what we will need to do is, as the rest of the columns except the price column is considered as input column, so if we just drop this column, then we can consider the rest of the columns. So we will write x equals to data dot drop. We will drop the column named price. So within parentheses we will write the name of the column, which is price. Okay, so another column that I want to drop is this furnishing status column, because you can see in the rest of the columns there are either numerical values, or if there are categorical values, they are either yes or no. So either 0 or 1. So we can kind of label them up within 0 or 1. But here in this column you can see there are 3 values each. It is either furnished, semi-furnished, or unfurnished. For dealing with this, we have to code it out a bit differently. I mean, we will have to use label encoding here, but that will require a bit more amount of code. So I don't want you guys to get confused dealing with this. So it's better if we just drop this column. So here I will write the name of the column, which goes by the name furnishing status. As we are going to apply the feature selection technique, we have to make sure that none of our columns in consideration have non-numerical values present. So every column needs to have numerical values, because only with numerical values we can apply the feature selection technique. So here we can see that in these columns there are either 2 values, either yes or no. What we can do here is that we can map these values to 1 and 0. So we can map yes to 1 and no to 0. So they all become numerical too, and then we can apply the feature selection technique. So now let's map these values. We will convert yes to 1 and no to 0. So we will write x. They are all inputs, so of course we will write x, and here now we will write x dot replace. Within parentheses we will map these values. So for yes we will convert it to 1, and for no we will convert it to 0. And we can run this cell now. Now let us check the shape of input and output values. For it, we will first check the shape of input values. So x.shape. So you can see it tells us that there are in total 11 columns. It would have been 13, but we gave away one column to the output values, which is y, and we dropped another one, which is this column. So in total, our column number becomes 11, and there are 545 rows for 11 of these columns. Now let's check out the y.shape. Here we can see that there is just one column with 545 rows. Next thing, we have to import the feature selection class. So for that we will write from mlx tend dot feature selection import sequential feature selector, this one. Okay, next what we want to do is we have to import a certain machine learning algorithm. We can choose any. I would be choosing the logistic regression. So let's import it from sklearn dot linear model import logistic regression. I know very well that we have not yet explored this machine learning algorithms such that of logistic regression yet in this series, but let me assure you guys that from the very next video we will be diving into this. And do not worry, we won't get into such depth in this video regarding this algorithms. I am using this just to explain you the concept behind the sequential feature selector, so bear with me. Okay, so the first thing that we want to do is we want to create an object for this class, so we can name it LR, and now we will call the class and we will run this cell. The next thing that we will do is we will create an object for this class. So let me paste it here, and we can name the object as SFS, and within the parentheses we need to pass a certain number of parameters, the first one being the name of the model, which is LR. The next feature will be K features, and what we mean by this K features is, for example, if we set it to 5, it will mean that the algorithm will end up selecting the best 5 performing features according to the scoring metric out of the 10 features. And if you specify it to 6, 7 or anything like that, it will select those 6 or 7 best performing features out of all the features. We can even set it to 10 if you want, but usually we try out different values and see which one performs the best. So let me set it to 5 here. There will be one other parameter which we will name as forward, and if we want to apply the forward elimination technique, we will set it to true. And on contrast, if you want to apply the backward elimination technique, we will just set it to false. So for backward elimination, set forward to be false. Next, we want these configurations that we made fit to our data set. So for that, we will call the fit function, and within the parentheses, we will pass the input features and output features. So let me run it. Okay, we are done calling it and fitting it to our data set. Now what we want to do is we want to find out the accuracy score that we get after the algorithm selected the 5 features randomly. So for finding that out, we have to call the kscore method. So I would write sfs.kscore, and I want the values in percentage. So for that, I will multiply it with 100 and I will print it. We got only 5% accuracy, which is way too low. Our motive needs to be increasing this accuracy score. So for that, we need to modify the number of features that we select here. You can try it out for yourself. You can try it out with different values and check it out for yourself how the accuracy score changes. You can also set this forward to be false and see how the backward elimination method performs in contrast to the forward elimination technique. I'm not showing it to you manually, but hopefully you will get it. Okay, now let's check the features that our algorithm selected. But before that, let's print the name of all the features. sfs.featurenames, and this method will print the name of all the features that we have in our dataset. So as you can see, these are all the features that we have within our dataset, and out of all these features, our algorithm randomly selected the best 5 performing features. So for printing the name of those 5 features, we have to call the kFeatureNames method. So kFeatureNames. So these are the best 5 performing features that our algorithm randomly selected. This will change as we change the value of key features. Let me show you how the accuracy score and the key features change as we change the number of key features selected. So now let me select 7 instead of 5, and let me rerun all the cells. So here are the results. You can see for yourself that selecting 7 features did not work well here. I think the algorithm performs best when lower number of features are selected. You can try 3 or 4 next and see how it performs. I hope you guys understood how feature selection works and applying the forward and backward elimination techniques. I hope you enjoyed the video, and if you learned something today, do not forget to click the like button, leave a comment and subscribe to the channel. I will see you guys in the next video. Until then, keep your mind sharp, your code clean and stay sane. The Naughty Samurai signing off.